This is a quick video to talk about file formats in SketchUp and more specifically exporting structures in SketchUp in order to 3D print them. So a few things up first, so some disclaimers. So there are of course several different versions of SketchUp all the way up through SketchUp 8 and then more recently SketchUp Make 2013, both a free and pro version, and SketchUp 2014, both the Make free and pro versions as well. Each one has some inherent ability to export structure files, and also there are many third-party plugins for being able to do that. So I'll go over a few of them that I currently have installed and that we have listed on the University of Richmond 3D printing blog, which is blog.richmond.edu/TI3D, and that stands for Thinking in Three Dimensions. So what I have here is just loaded up a simple object created from three different components, and so they would ordinarily fit together if you 3D print them into a puzzle of sorts. So with exporting the file formats, the most common file format for 3D printing is called an STL file. That's the file name extension, and that stands for stereolithography. A STL file only contains the shape information, the surfaces of the object, where they intersect, where the edges are bound between intersections. It doesn't contain any color information. So it's the most appropriate file because of its ubiquity for cases in which you're going to 3D print something and will not be using the color information within the 3D printer. Of course, several 3D printers use a particular color material, but if you're using a single color for the material of the 3D printer, the file format does not need to contain that information. So again, STL is the best format. For color information, it becomes a little bit more confusing. There are at least 4 different file formats that are pretty common. One of the best printers out there for 3D printing in full color is a printer that is a series of printers that 3D Systems makes. Originally, the company was called Z Corporation. They were bought out by 3D Systems. So you'll typically hear Z Corp or ProJet 200, 300, 400, 600, 800 line printers. And so in effect those are the ones that will do color printing. And there is a proprietary file format that works very well with the printing software that drives those printers, and it's called a ZPR for Z Corp printer file. And a ZPR file does contain the color information as well as many other optional characteristics and properties of the designed object. And so it really depends upon the features that your 3D design software have for being able to export some of that information into the ZPR file for the color 3D printer. But then there are other file formats that are of course not as proprietary. So one of them is VRML, for I believe it's a virtual reality markup language, and a VRML file very much allows one to be able to store this additional information such as color into the file. And it's pretty commonly used for a lot of CGI software and CAD software, as well as 3D printing for colored objects. Another file format is PLY format, and that again can contain color information. And then another one which gets a little bit back into proprietary to some degree is 3DS, and that's from 3ds Max, which was or is a popular CGI software application. So my recommendation is typically if you're going to be printing specifically to a Z printer, then a ZPR file is best. And if you're not sure where it's going to go to, then a VRML file will be sufficient. Again, for situations where you're using color. And as well, STL file if you're just sending the design to the printer without color information. So here's my object with 3 different components. Most of these plugins and export functions will act upon the entire design, anything that you have within your design world, if you don't have any particular object selected. If you have a single object selected, I'll get the selection tool and I'll triple click on an object. Oh, this one was already grouped, so if I single click it, it'll select the entire group. Now the export function will work typically only on this one object. So let's go through a couple of the plugins. Now the oldest one that we have used in the CTLT is available if you have it installed under the plugins, under the tools menu, and it says export to DXF or STL. Now DXF is an AutoCAD file format, but the STL one is the one that we care about. So we click that, and you'll need to export your units. And the units are pretty important, but most printers, 3D printers, will have the capability of rescaling something if you had set the wrong units in this step. Nonetheless, I'm using a template within SketchUp that uses millimeters, so I'm going to export my design in millimeters. So I make sure I select that and hit OK. Then the next option is export to DXF. Well, I actually don't want to do DXF, but you'll see when you click the pull down menu that there are several different options. And if you were going to a more CAD, computer assisted drafting and design world, then you might want to select some of those first few options. But we want the STL or last option. So we select that one, hit OK. And then it's going to ask you where you want to store that file. And with some of these plugins, it automatically goes to the desktop or your home folder on the computer, and you don't have a lot of options. You have to then start navigating around where you want it. Nonetheless, you can just hit save, and it'll export it. It'll typically tell you how many faces it exported. In this case, so you can probably count up the faces and get a good guess whether it succeeded in what you were wanting to do. And then it'll often say how many objects are ignored, and it's going to ignore the actual edges themselves, the actual lines, because those don't have any substance to them, so they're not going to be able to be 3D printed. It's going to be the bounds of the surfaces and where they intersect that create the actual volume that gets 3D printed. So anyhow, this is just a simple rule of thumb. And basically, in this case, looking through this, I would say that it succeeded. And the only real test is by importing that STL file into your 3D printing software with your printer, because it's going to spend some time analyzing your structure and deciding how well it can print. Now, if you wanted to select all three objects, you could use on a Mac a Command A function to select all of them in SketchUp, or you can use a bounding box and with a selection tool, just go somewhere into that gray part, click and drag the left mouse button and the mouse over until you have all three objects selected, and then let go. And of course, you want to make sure that you have the entire objects selected, not just half of the object or one face of it. It has to be the entire objects. And so then I could do it again, Tools, Export, make sure millimeters is selected, hit OK, make sure I hit STL, and hit OK. And I can hit Save. In this case, I let it overwrite an existing file. You'll see this time it had several more faces that it exported. You also see 0 lines and also 106 objects ignored. And hit OK. And again, you would then want to test that by importing that into your 3D printing software. So that's just one of the export functions. That's using one plugin that's called Export to DXF or STL plugin, and that was installed specifically into this SketchUp, and it is, again, a third-party plugin. So there's another one that we've been using most recently, and that one can be found under the File menu. It's under its own section. It's not under the normal Export section. It's under Export to STL. And when you click that one, you now have a few more options. Export the selected geometry only. Right now I have nothing selected, so I don't want to have that selected. What units do I want to use? In this case, millimeters. And what is the file format? Typically you're going to want to use binary. It's going to be the most efficient file format, and more of the 3D printer software will read binary files. So I hit export and I save it wherever I'm going to, and again that will create an STL file. Another one which is using that original plugin that you may have noticed is that export to DXF or STL. So they just put on the file menu as well. Now for the SketchUp internal methods. If you go to the file menu and mouse over export, you can then get to 3D model. And once you get to 3D model, you have a normal file window that appears, and then you'll see format, and you have a number of different formats that you can export in. So I mentioned earlier 3ds or 3ds Max file format is one of those that will allow you to export the color information. And on each of these, for example, if I select 3ds, you'll typically have some options, and you click on options and it'll give you what choices you want in exporting your file format. So it's probably best not to alter any of these if you're going to try to use these file formats without knowing more fully about that particular file extension and the main software that uses it. So in this case, knowing more about 3ds Max. So let's say we pick one of the other file formats that I mentioned, and if you look at this list, the ZPrinter ZPR file is not listed here, but you do see Vrml file, and the actual file extension is WRL typically. But you'll also see .vrml in some applications as an option. So I'm going to click that. Again, I have some options, so I'll click that. Use Vrml standard orientation. I typically would do that. It's not really going to matter much. It just orients the object to be more consistent with the Vrml language and makes it slightly more standardized or even slightly more oriented piece that is consistent with the way software will import a Vrml file to try to reduce possibility of errors in the import process. Allow mirrored components. I don't think I'll select that. I guess if you're working with particularly mirrored components in which you created something called components in SketchUp, and then you've made some of them rotate such that they're mirrored from each other, then you'll want to use that. But typically you'll know when you've used that feature within SketchUp. I would leave the rest of them there. In the case of Vrml, it will allow you to export the edges, which can be useful, especially in some software that will try to analyze your object to make sure that it is printable. And so we'll just finish that out and hit OK and hit export. It'll tell you what it's trying to export, SketchUp into entities processed, how many groups. I actually had 3 groups of objects. There were 40 total faces, 106 edges. There's one camera, that's just the default for SketchUp, which is of course your view into the objects. And 7 materials. You'll notice that I had colored objects, so between the different shadings and whatnot of white and pink and yellow, I ended up with 7 materials. And then lastly, I'll tell you what actually got exported, and hit close. Okay, and so in effect you can then use that WRL file with your 3D printing software. So common problems with exporting. So I said the most common is that you only have part of an object selected. So for example, if I have this object, and let's just say it's not grouped, so I'm going to explode it. And I now have this object, and let's just say I've then selected only part of it. Okay, and then try to export that. My bad. Let's just say I have part of it selected. I'm going to go off and try to export it. It's probably going to let me do it, and I'll even try millimeters. I'll say I want an STL file, hit OK, and give it a place to put it, and overwrite an existing file. It's going to say that some faces were exported. It's going to talk about some things that were ignored. but I won't know until I open up my 3D printing software whether it actually exported anything more than those 4 faces, which don't actually even constitute a solid object. So that's probably one of the most common problems that can arise. So the best way to solve that is by having your objects grouped. And so like in the case of this, on this L on the right hand side, if I use a selection tool and I single select it, it is a group. But on this middle case, as a better example, since I don't have it grouped currently, the best way to make sure I have the whole object selected is by doing something called a triple click. Now I just clicked it once and that just selected the face. If I double click it, it's going to create select the face and all the bounding edges for that face. However, if I triple click it, 1, 2, 3, it will now select that face, all the bounding edges, and then all of the faces and edges that are in any way adjacent to that former selection. In effect, a triple click selects the entire object. In SketchUp, I would best then right click on the mouse and then make a group. And once you have a group, then it's much easier to select it and make sure that you've selected the entire object for exporting. So that's probably the most common problem. That is, let's say, lowest hanging fruit. The more difficult issue is if you have something that is not 3D printable. And this typically will not cause an error in most export steps. It will cause a bigger problem in the step of importing it and or analyzing your object for 3D printing. But let's just say, for example, that on this object on the right hand side, my object doesn't have one of its faces. So I'll explode it and I'll just delete one of the faces. And so now you look and you can see that there's like a hollow box aspect to that L shape. So if I select this object, 1, 2, 3, triple click it, and I go to Tools, Export, Millimeters, STL, OK, and give it a file name, it'll probably export it. It'll say faces and all that kind of stuff. It's not going to tell you that there are any problems with it. So this isn't going to be able to go into all the matters of checking to see whether something is 3D printable and or might cause a problem with the export. However, what one can do at least is give you a few short tips about this. And so when you triple click an object, you can set it as a group if you so choose. And there are some plugins for helping check whether that is going to be 3D printable. And so we have a couple of them installed here. The first one, if you go to Tools and down to Solid Inspector is a third-party plugin. And when you select it, it's going to highlight your object. It's going to try to use red lines or curves for the actual errors in the object, and you'll see how it's made those red lines around that one face that is missing. And then it also circles the entire area to help give you an idea for seeing it. This is very useful if you have a very complex object with, for example, thousands of faces. And so this will help clue you into it. However, as soon as you start orbiting around your object, you'll lose all of that. You'll lose it. So Solid Inspector is very much tied to the angle that you're looking at. So if you change the angle, you're going to have to run Solid Inspector again to again be able to use it. Also, Solid Inspector does give you some clues down in the status bar for how to use it. So you'll see click on solids to inspect. I currently have done that. Use arrow keys to cycle between the errors. So if you have multiple errors, you can use the up and down cursor keys on your keyboard to cycle back and forth between which ones are highlighted to show you all the errors that are in your object. And then press return to zoom in an error. If you hit enter, you'll now see that it has zoomed the extents of SketchUp to be able to focus on that particular problem. Now I can't go through all of the matters of trying to fix this kind of problem. In this case, it's a very simple face. One can select those 4 edges, for example, So I'll go ahead and do that. So selection tool, and I'll press 1. I'll hold down the Option key and select the second, select the third, and select the fourth. And I have a third-party plugin installed called Make Faces, and so I can select those 4, and I can go to Tools and Make Faces, and it will mathematically try to fix and create a single surface that is coplanar with the 4 lines segments that I had selected. And if it succeeds, you should see it disappear. It'll give you a small report of how it worked. And then you can hit OK, and then you're hopefully done. And so now if I select the object again, go to Tools and Solid Inspector, you'll see there are no problems with it. So that's a good sign. So again, this won't necessarily work for every situation, but it will work for some. Okay, so what is the main purpose of selecting something and finding out whether it's solid or not? So for the 3D printing software, it needs to make sure that there are no small gaps or holes in your object, that things are in shells, meaning in this case of this L shape, there is a single shell. There is an inside to the L object, which is empty space, and there are all these bounding faces that create the actual object. And if there was a little gap between 2 of those edges, most printing software will not have an easy time determining what is the inside of the object and what is the outside of the object. That is, where should it be adding the 3D printing material, whether plastic or powder or even liquid resin. How's it going to actually create the object? Another term for this is called manifold, making sure that your object is manifold. And so the Solid Inspector is one tool for doing that, and different 3D design applications have different tools for doing that. So if I open up a browser window and go to cloud.netfab.com with 2 B's, there's a website that Netfab manages and hosts using Microsoft Azure, and you can upload your 3D models into it. It will automatically repair them, and then you can download them for free. Of course, if you're going to do this on a very regular basis, it might be better to actually go ahead and purchase Netfab. Nonetheless, you can click on Sign In and put in your live account, and then you can upload your design. And so I'll go to Thingiverse. I'll just upload any particular one, I guess Final. I hit Open. It'll say that it's uploading, so that's queuing. It's going to say that it's repairing. And this is much better than an earlier version of Cloud Netfab was. And in the earliest versions, you would upload it and have to give it your email address, and they would email you a link to be able to download your model. But it's much faster now that it's on Azure. And so as soon as it's done repairing, you can then click Download and download your fixed object. It's waiting a little bit. Let's see in the status bar. But it'll finally download it, and typically it appends an underscore fixed to your file name. Thank you for watching.